Hi! Welcome to our video, and this is for our grade 7 mathematics, and our topic for today is all about sets. Okay, this is for our quarter 1 week 1. Okay, and our objectives, we would describe and illustrate the well-defined sets, subsets, universal set, null set, and cardinality of set. Okay, these are the one that we would describe and illustrate later on. And now let us continue to the well-defined sets. And here's the definition for our well-defined sets. It is a collection of distinct objects. A set is a well-defined group of objects called elements that share common characteristics. And here are our examples of well-defined sets. The first one is we have the set of fruits. Okay, now the set of fruits. So as you can see, these are our set of fruits. We have the apple, banana, mangosteen, orange, and pineapple. And in order for us to write the set, it would be enclosed by a bracket. And let's write apple. So now we have apple, and then followed by a comma, and the next element. We have banana, then mangosteen, orange, and pineapple. Now take note, as you can see here on our set of fruits, apple, banana, mangosteen, orange, and pineapple are our elements. Okay, they are our elements that share a common characteristic. And what is that common characteristic? They are fruits. And how could we say that they are, or this set is a well-defined set? It's because the elements contain a common characteristic. It's because they have a common characteristic, then therefore this set is a well-defined set. Now, for example, we have apple, banana, mangosteen, orange, and pineapple, and then we would add, let's say, notebook. For example, the sixth one here would be notebook. So if we would add notebook on this set, then therefore this would not become a well-defined set. Okay, so the set of fruits are only consisting of fruits that shares a common characteristic, or being a fruit. And the set of fruits could not only limit to pineapple. We could still add all of the fruits that we know could be added in here on our set of fruits. Okay, now let's continue. Let's have this set of animals. Okay, our set of animals, the first one, we have the cow. Then second, we have the cat, dog, bird, and the butterfly. Now, all of these are animals. Okay, even though they have, or they are on different families, the point is they are animals, and the set of our animals are cow, cat, dog, bird, and butterfly. As long as they are animals, then therefore this set is considered a well-defined set. Okay, how could we make it as not a well-defined set? For example, we would add, let's say, pencil. We would add pencil here, like cow, cat, dog, bird, butterfly, pencil. Then therefore it is not a well-defined set anymore. Okay, and the set of animals does not only contain these 5. There are a lot of animals. Then therefore we could add as many elements as we wanted, as long as they are animal, in order for us to have this set of animals. Okay, let's add lizard. We would add dolphin. We would add whale. Those are animals. Then therefore they belong to the set of animals. And let's continue. And as we go through with our discussion, we would always use this one. We have the set of numbers. Okay, the set of numbers we have, this is just a finite set of numbers, wherein it consists of 1, 2, 3, 4, and 5. Take note, I wrote here set of numbers because there are many kinds of numbers, right? We could have the set of real numbers. We could have the set of the positive integers, the set of, let's say, negative integers, or the set of natural or counting numbers. Okay, so there are a lot of kinds. And in this example, you only have the set of numbers, a finite number consisting of 1, 2, 3, 4, 5. Now, if we would write here the set of real numbers, then we would include all of the real numbers in our set. Okay, this is just an example of what is a well-defined set. Okay, what would make this as not a well-defined set? If we would add an object or an element that does not share a common characteristic with numbers. Let's say 1, 2, 3, 4, 5, and then you would add letter A, you would add letter B. Therefore, it would not become a well-defined set. It's because letter A and letter B does not share a common characteristic of which of the numbers. Okay? And for example, we would continue this like 6, 7, 8, 9. They are still considered as a set of numbers because those numbers, the elements that we have, share common characteristics. The important thing when we say set, they share a common characteristic, and that is how we will define them. The elements share a common characteristic. And now let's continue. Let's go to universal set and subsets. Okay, let's continue to universal set and subsets. So the universal set, having the symbol U, italicized U, the set containing all objects or elements and of which all other sets are subsets. Okay, this is now our universal set. And we also know that the universal set is the set that contains all elements under consideration. So meaning if later on, let's have the examples of that. Now, let's proceed to subsets. Subsets is a part of larger group of related things. A subset is only a part. It's only a part of a larger group. Okay? And it is also a set of which all elements are contained in another set. Those are subsets. So, universal set and subset. In order for us to further understand this, let's have an example and let's go to the set of alphabet. Okay, the set of alphabet. As we all know, the set of alphabet, how many? It contains how many elements? On this one, we have 26 elements, and those elements are A, B, C, D, F, G up to Z. So these are our elements, and the set of alphabet as a whole is considered as our universal set. Okay? So, meaning, all of these elements together in one set, then it is our universal set. Okay? Now, let's have subsets. Let's have a subset. As we mentioned earlier, a subset is just a part of a larger group. So, meaning, it is just a part, not as a whole. So let's have this example, set number 1, and having the elements of A, B, and C. So what could you notice? On our set number 1, as subsets, it is just a part of the set of alphabets. ABC, and the set number 1 is ABC. Meaning, set 1, its elements are contained in another set, which is the larger group. Take note, the universal set is much larger than the subset because a subset is just a part of a larger group. Let's have another example. Set number 2. Set 2 is equal to having the elements of I, J, K, L, and M. So I, J, K, L, and M rather are being contained by our universal set or by our larger group. And let's have another example. We have set 3 having an elements of A, B, S, T, W. Okay? The main point here is that when we say subset, it is just a part. You can always see the subsets on a larger group. Okay? So this is the set of alphabet is our universal set. Then all of these sets are just a part of the larger group, and that larger group is the set of alphabet, and the set of alphabet is what we considered as our universal set. It's because it is the set that contains all of these elements under consideration. And let's continue to our next example. So our next example would be subjects. Okay, subjects. Okay, as a student, these are from grade 7 to grade 10. These are your subjects, right? You have mathematics, English, Filipino, ESP, AP, MAPE, TLE, and science. These are your subjects. Then therefore, we can consider this because as a whole, these are all your subjects. Then this set is our universal set. This is an example of a universal set because these all are our subjects. And now, how could we make a subset out of this? For example, among these subjects, you have your favorite subject, right? For example, you have your favorite subject, and your favorite subject is just, except if all of these are your favorite subject, right? But I guess not all of these subjects are your favorite subject, then therefore, your favorite subject would be just a part of these subjects. And let's have that yet. Okay, for example, your favorite subjects or subjects are only ESP and MAPE. So these two are your favorite subjects. Therefore, your favorite subjects is just a subset. Okay? This is just a subset of our universal set. A subset of our universal set because this is just a part of the larger group. Okay, let's continue to our example and let's go to numbers. Okay, on numbers, for example, we have set A. Our set A contains the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is just a finite set only consisting of elements 1 to 10. And example of our subset is 1, 2, 3. Set B is a subset having the elements 1, 2, 3. Another example of a subset is set C having the elements 4, 5, 6, and 7, and 8. And set D having an element 10. Okay? Its element is only 10. Now, as you could see, set B, C, and D are all subsets of our universal set, which is A. Our universal set here is set A, and set B, C, and D are just subsets. They are subsets. It's because they are just part of the larger or the bigger set. And set A is a universal set. It's because it contains all of the all of the elements rather. It contains all of the elements of set B, C, and D. Okay? That is for, I guess that is for our universal set and subset. The gist of it is that if it is a large group containing all elements, it is considered as our universal set. If it contains the elements of other sets, then therefore it is a universal set. And if it is a subset is just a part of a larger group, or we could say it is just a part of the universal set. Meaning, its elements are all contained by the universal set. And let's continue to our third objective, the null set. Okay, the null set, these are the symbols for the null set. Or this one, they're just the same. They are read as null set. Okay, by definition, null set is a set that does not contain anything. It is a set that has no elements. It is a set that contains no elements, or for short, it is an empty set. Meaning, it has nothing. There's no element on that set, and that is a null set. Null set, as easy as that. If you would see a set that contains no element, then therefore, it is a null set. Okay? Now, let's continue to our cardinality of set. Now, cardinality of set is the number of elements contained in the specific set. Meaning, it is just the number of elements. Meaning, you would count the elements. How many elements are there how many elements are there on that set, and that is the cardinality of set. Let's have an example. So let's use our example on numbers. Okay, for example, we have set A. For set A, in order for us to identify the cardinality, we would just simply count. We would count the number of elements. On this case, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Therefore, the cardinality of set A is equal to 10. Now, we are using the symbol of absolute value. This is the symbol of absolute value, but if we would read this, this is the cardinality of set A is equal to 10. Let's continue. Our set B. What is the cardinality of our set B? And it is simply, let's count, 1, 2, 3. So the cardinality of set B is 3. Let's have set C. The elements of set C, we have 4, 5, 6, 7, and 8. And in order for us to find the cardinality of set C, we would just simply count 4, 5, 6, 7, 8. Let's count the elements. Then therefore, the cardinality of set C is equal to 5. And for the last one, set D. Okay, the cardinality of set D. Let's count the elements. It's 1. Then therefore, the cardinality of set D is equal to 1. So for example, let's say you have a null set. You have an empty set. So what's the cardinality of the empty set? Its cardinality would be 0, okay? Because by definition, when we say cardinality of set, it refers to the number of elements. And if we're referring to null set, empty set, and there is no element on that set, then therefore, the cardinality of that set is 0, okay? And just a reminder, when we say null set is always, okay? Null set is always a subset. It is always a subset of all of the sets. In every set that you know, and every set that you have, a null set is always a part of those sets. Okay? And lastly, the last that we would discuss are the symbols. As you can see, symbols are not on our objectives. It is not on our objectives, but as I have noticed on the module, there are a lot of symbols that are present that you need to know what are those symbols. Because if you do not know what are those symbols, then we would have a problem on understanding our module. I included symbols. It's because on our module, there were a lot of symbols that was mentioned. And the one that I would discuss here are just few among the symbols of sets. Because if we would talk about sets, there are a lot of symbols. There are just only few of them. And let's proceed. So here are the symbols that we would discuss. This first symbol is no need to discuss because we have a lot of examples like this earlier. This bracket refers to a set. And let's continue to this one, such that. It is read as such that, and it means so that. Okay, for example, if we would read this one, A is equal to X, such that X is an element of real numbers where X is less than 0. Again, this is such that. Next, this one, this symbol, this is read as subset. A is a subset of B, meaning A is a subset of B wherein A is included in set B. This example, as you can see, the elements on set A are 9, 14, and 28. It is a subset of set B wherein it contains all of the elements, meaning they are also equal. When we would use the symbol, it means that it is a subset, but on the same time, it also contains all of the elements of the other set. Let's proceed to this symbol. This symbol, it is read as proper subset or strict subset. Now, let's read this one. A is a proper subset of B. It means A is a subset of B, but A is not equal to B. Let's look into these examples. A is a proper subset of B. When we say proper subset, it means it is a subset containing parts containing parts of the other set. As you can see, our elements are 9 and 14. These two are only parts of set B. And the last one, the last symbol that we would have for today, this symbol, it is read as not subset. A is not a subset of B. That's not subset. Meaning, A is not a subset of B. It means that A here, on our example, A is not a subset of B. Why? A contains the elements 9 and 66. And on set B, there is no 66. So that is why it is not a subset. And I guess that would be all for today. And before I would forget, let's go to cardinality of set. Let's go back first to cardinality of set. I almost forgot. Okay. On the cardinality of set and on the examples, earlier we said that this absolute value, I almost forgot, this is also read as the cardinality of A is equal to 10. Sometimes on cardinality, some are also using like this. Okay. This is also read as the cardinality of set A is equal to 10. Okay? So they are just the same. They are just the same. The cardinality of set A is equal to 10. The cardinality of set A is equal to 10. And I guess that would be all. Thank you so much for watching our video. If you have questions, you may comment down below or you can post your comments on our page. And I guess that would be all. God bless you all.